to look at the kinds of combinations that particular strip patterns might have. As a start, what I want to do is I want to remind you that strip patterns can have any one or more of the following types of symmetry. They can have translations. All strip patterns have to have translation symmetry, otherwise it's not a strip pattern. They can have horizontal flip symmetry. Some patterns have vertical flips. Some patterns have glide reflections, which I will simply call glides in this video. Some patterns will have half-turn rotations, but every single strip pattern, all of the symmetries that it has, will fall into one of these 5 types. So what I want to do is I want to look at the various kinds of combinations that strip patterns might have. First of all, we can have strip patterns like this one that are made up of an asymmetric repeating shape, and the only symmetry we have is the basic translation. I can take this left foot to this left foot, and when I do this, the whole pattern moves 1 foot in the direction to the right. And this line down here is the distance between the footsteps. In other words, this line measures the distance from one heel to the next heel. These patterns are not very interesting. The next kind of symmetry that we can have are translations and vertical flips. Now, if we look at this particular pattern, what we see is that we have pairs of footsteps that have clear vertical symmetry between them, and the basic pattern is made up of 2 footprints that are facing each other. And if I want to do the translation, the footprints go like so. They hop like that. But it's important to realize that these footprints have vertical symmetry as well. Not only can we reflect this one over that one, we can reflect this one over this line to get this one. And so we have this set of vertical mirrors that is shown in blue. In general, if I'm reflecting over this mirror, this footstep goes to that one, this footstep goes to that one, and so on. So the whole pattern lines on itself. So this is what a pattern that has translation and vertical flip symmetry and no other symmetries, it's what it would look like. So the next kind of strip pattern combination of symmetries that we can have are strips that have translations and half turns and nothing else. And they typically look like one of these 2 kinds of strips. They are made up of an asymmetric shape that either occupies about half of the width of the strip or it occupies the whole width of the strip. And to get the repeating part of the pattern, you take that asymmetric shape and you rotate it. So this is a left foot, and if we rotate it by a rotocenter about here with a half turn, this left foot will go into this left footprint. Down here, the rotocenter is about here, and this foot will rotate into that one. The translation for this kind of a pattern is made up of 2 of these things, and it's this long because you have to take those 2 footprints into these 2 footprints, and these 2 footprints into these 2 footprints, and so on. Down here we get a similar kind of thing. This is the basic building block on the translation. We take those 2 footprints and we move them to these 2 footprints, we move them to these 2 footprints, and so on. The rotocenters are between the footprints because the shape that we are using is not symmetric. And the rotocenters are shown in blue here. And we can see how the rotocenters work by looking at the first 2 footprints. And if I do half-turn rotation around that particular blue center point, you'll notice that this one lands on that one and vice versa. So let me just do that again. Similarly down here, if I rotate about a rotocenter that is between the 2 footprints, I can have the 2 footprints land on each other. We also have rotocenters that are between the heels of the footprints. And in this case, I'm going to be revolving where this footprint is going to land on that one. And you can see how that works. And if I did the whole strip, what would happen is that this whole part of the strip lands on this whole part, and this whole part lands on that one. Similarly, if the pattern is squished where the asymmetric footprint is taking up the whole width, the rotocenter between the heels still lets me take one footprint to the next one. That's the only kind of symmetry that these two strips have at all. They don't have a horizontal flip, and they don't have any glides. The next kind of strip patterns that we might look at are strip patterns that have only glide symmetry and translation symmetry. Now, the translation symmetry is the two footsteps here. This is a left one and this is a right one, and you'll notice that this is basically nothing more than a common footprint trail like ordinary walking on a beach. And the translation takes the first two footprints into the next two, and it takes them into the next two like that. So that's how the translation works. It's important to realize that under the translation, the left footprints are going to left footprints, and the right footprints are going to right footprints. Now, down here, we've got a situation where we're still alternating left foot, right foot, left foot, right foot. It's just that this time the footprints are taking up the full width of the pattern, and what that basically means is this is like walking heel to toe on a straight line. But the basic pattern is made up of a left footprint followed by a right one, and again, the translation is always going to take left footprints to left footprints and right footprints to right footprints. Now, I want to think ahead about what else is going on. In both of these, there is a middle line in the strip, and I've just shown it. Now, clearly, we do not have horizontal symmetry, and that's because these left footprints are not being reflected down into right footprints that are below them. But it's important to realize that if I did look at this particular footprint and reflect it across that line, it would look like this. And then if I do a translation, it would land on that right footprint. Now, what I just did is a glide. I'm taking this footprint, reflecting it across the horizontal line, and then translating. If I think about that and I do it again, a glide operating on this right footprint is going to flip it back up there, and the translation is going to go to here. So two glides is going to be one translation. This strip pattern has a similar property. If I look at this and I reflect it, it's now been reflected directly across that line, and when I translate, I land on the next right footprint. So it's important to realize in these glides that the glides are only half as long. They are taking this footprint into this footprint. And so the glide is the distance between two footprints. So that's where the glide distance comes from. Doing the glide a second time, as we saw before, winds up being the full translation. The same thing happens down here. If I take this and I do the glide, I do the reflection first and then the translation. So the length of the glide is the distance that I have to go from the back of this foot to the back of this foot. Now, the upshot of this is that glides are half as long as the basic translation in this kind of a pattern, and two glides equals one translation. That's the thing that characterizes a strip pattern that has only glide and translation symmetry. So the next kind of strip that I want to look at are strips that have clearly translational symmetry and a horizontal flip. Now they basically are made up of one of kind of two things. You can either have a single unit that is got a horizontal flip, or you can start with something that's asymmetric like this left foot and flip it over a horizontal line to get the right foot. So in this particular strip pattern, the basic repeating image is made up of both feet, a left foot and a right foot. And the translation is exactly what you think it is. We hop from one set of footprints to the next set of footprints to the next set of footprints and so on. Now I want to get the horizontal line drawn. So we draw the horizontal line, and it's easy to see that the left footprints and the right footprints are mirror images. If I take this particular left footprint and flip it over, when I flip it over that line, it's going to land on that left footprint. If I look at the pair of footprints together and I flip them, they will be flipping over that blue line, and what I want to notice is I don't see any difference. So if I flip it again, I still don't see any difference. In other words, all of the left footprints land on the right footprints through horizontal flip and vice versa. Now the neat thing about having both a horizontal flip and our usual translation symmetry is that it's going to force us to have a glide. And I want to look at that. It turns out that if I'm looking at a glide, I want to take the first left footprint, I want to flip it upside down so it lands on this footprint, and then I translate it to come over here. So the glide is taking the left footprints into the next right footprint. It takes this left footprint into this one. It takes this left footprint into this right footprint. It takes this left footprint into this right footprint. And it also moves the right footprints to the next left footprint. In other words, this right footprint, when I flip it upside down, it gets reflected to there, and when I do the glide, it moves over to here. So this right footprint moves to that left footprint, and so on. So the length of the glide is, again, the length of the distance between footprints. So right here, we started with, just to make it clear, we started with this particular footprint. We reflected it to get up there and then did the translation. So to go from this footprint to this one is a glide of that length. Two glides, if I think about doing two glides, so let's get this out of the way. If I think about doing two glides, the first glide is, of course, going to take the left footprint into the next right footprint. The second glide is going to take that right footprint into the next left footprint. So two glides takes this left footprint all the way over here, and it takes this right footprint all the way over here. In other words, two glides equals a translation of twice the length of the basic translation. And that's what this basic note is saying, is that if we have this horizontal flip, then the glide is always going to have the same length as the basic translation, but two of these glides are going to be a translation going from here to here. The operation between a glide and the translation is also important. The translation takes this left footprint into this left footprint, and this right footprint into this right footprint. The glide takes this left footprint down here to this right one. So the glide and the translation even though they have the same length, are not the same symmetry operation.